Hey everyone, this is Derek, and this is going to be the first of three videos. They're kind of a review of logs and exponential functions, but mostly, almost entirely focused on natural logs and the natural exponential function. With that, I'm actually going to start with a couple that are not natural logs. These aren't on the homework. This is just to try to help you kind of remember back to your intermediate algebra and how logarithms work, and I think they will make more sense with some numbers in them, and then I'll switch over to the ones that are base E, but I think those are a hard one to start off with. So let me remind you kind of how logs and exponentials work, and that's pretty much what this first video is about, is that there's two forms for logs. There's a log form and exponential form, and we're going to kind of practice getting back and forth between them. So actually kind of two separate things. Let me start over here with just a really brief reminder of, again, this is sort of our intermediate algebra or Math 116. If we have an exponential function, those are those ones that grow really fast. Those are of the form y equals a to the x. If we have a log function, those are the ones that grow really slow. Those are of the form y equals log base a to the x. So that's kind of the two different functions going on. And those are absolutely entirely separate things. That said, with a log, we can write a log in two different forms. We can write a log in log form and exponential form. And so I got to be careful when I'm talking about these to not confuse you with, when we're switching forms in a log, it's the same thing. We didn't magically turn it into an exponential. It's still a log. We're just putting it in a different form. And what we'll find is these two things are what are called inverse functions to one another. And so when we have an exponential function, we're going to solve it using logs. If we have a log equation, we would solve that using exponentials. So these two kind of also go backwards and forwards with each other in that inverse relationship. But this thing that I'm about to show here is I'm going to write this as, it's going to be that base a raised to the y equals x. So see, it's not the same thing as the exponential. The x and the y have swapped places. So these are our two forms of a log. This is a separate thing. That's an exponential. Okay, so we're looking at this right here. So with this one, write in exponential form. So we have a log, it's in this form, and we're trying to write it in exponential form like this. And so the way these work, it goes log base b of x equals y, and then it's b raised to the y equals x is how we get into exponential form. So the base raised to the answer makes the stuff inside, and that's what this is right here. So here this says log base 10 of 100 is 2, so this is 10 raised to the second, that's our power. The answer to a log is always a power, it's the exponent, and that equals 100. So I think it makes a lot more sense if you can kind of see the numbers. This is log base 10 of 100 is 2. In other words, what power do I raise 10 to make it come out to 100? 2. And this is saying, yeah, 10 squared makes 100. So they're saying the exact same thing. Again, it's asking the question kind of forwards and backwards. This one, so this is written in this form, and we're trying to get to that form. So notice in the exponential and the log, the base stays the same. When I'm doing the log ones, I kind of have this swoopy thing that I start at the base, go to the answer, and come back. And that kind of keeps me organized. This one I have a little bit harder time with. And what I realized is that the base of the log and the base of the exponential have to be the same thing, right? So that's going to be log base 3. And then it's the other two things that swap sides. Plus the answer to a log, that's your exponent. So that kind of helps you go, okay, so this is 81 equals 4. So what do I raise 3 to make it come out to 81? 4. And so that's what this first video is about, is basically just being able to go back and forth between those two forms. And there's good reasons for both, and we'll see them as we go on. So now I'm going to do this, but I'll do it with the base E. Okay, so this is the definition I just brought over from the last page. First, let me kind of back up to natural log, just reminding you what that is. That's our regular log. It's a base E, and we use it so much it got its own name, and it's natural log. So that is not IN, that is lowercase ln, as in log natural instead of natural log. So ln x equals y would be our log form, and then picture that little invisible e right here, right? So e raised to the y makes x. So e to the y makes x. So that's our exponential form. These are asking us convert each exponential equation to a corresponding logarithmic equation. So we're in exponential form and we're trying to get the log form. So for that, we'd have natural log. Remember that e, okay, so this is my own little neurotic thing. I do not like the p on that side. I like it written in this direction. And these problems on the homework wrote it that way. And that's all fine. I prefer that direction. So I'm going to do that. So natural log, that's going to take care of the e because remember that has that little base e. So that's where our base is going. Of the answer, we don't want to type the e though, equals the exponent. And when I was a student, I found this super duper confusing. And what I kept writing over and over was that basic one I started with. Log base 10 of 100 is 2. And I could go, okay, because 10 squared makes 100. And that would kind of help me orientate. Okay, so this would be e raised to that makes that. Yeah, okay. And I would use this to kind of help orientate my brain on the rest of them. This one, again, I'm going to rewrite it in the other order just because I prefer to. And so then we have natural log, e is the e, the 13 comes over to this side, exponents on the other side. And that's all that's looking for. It's not looking for you to do anything else with it. Number 4, this is asking you to go the other direction. And so I'll do the same thing. I'll just rewrite them in the order that I prefer. So now here's where kind of for me, I'm picturing that little invisible e right there. I'm going that to the 4th makes the 5. It's not that I can't do it that way. I do. And that's it. It doesn't want you to isolate the x or anything. That's all it needs. And then here, so again, picture that little e. So we'll have, that's our power, and then that's what it'll equal. So e raised to x plus 3 equals y minus 7.